Okay, so welcome to CodeCraft. This has gone from less from discussion to becoming a class, I think. There's some setup of like why are we talking about this? This week on Archmage, we were faced with we have a lot of issues working on the existing code base, and we'll see some of those reasons in a second. But anyways, we're faced with that, and I am trying to fix a bug for Tyler. That's right. It's for him. I guess it's for everybody, but Tyler's the one who identified it. And I'm trying to fix it. And I ended up going, oh man, this is like a total rewrite. Right. And so there's a couple of questions that come out of that. How do you reach that conclusion that this is a rewrite, right? Why can't we work with the existing? And then the second thing is, how far does that rewrite go? How do you know to go here and no further, right? Like God with water. Here and no further. We'll talk about that, and hopefully can give you some tips on how to do that. And if I haven't, then you can ask the question again at the end. Okay, so let's start with who's Joel on software, because everybody here was like, who's Joel on software? What are you talking about? Has anybody, Zach, have you heard of Joel on software? Tyler?
I had not, no.
Okay.
The name is familiar, but I wouldn't know who he is.
You may just have a friend named Joel.
I might just have a friend named Joe. Yeah.
Yeah. So Joel on software, he's been publishing and talking about software development since 2000. So basically around the time that I got real serious in 99, even a little few. Anyway, he's been in software, I guess, about as long as I have, and he's created way more and impressive things than I have. So these are three of the things that you may have heard of. Maybe you haven't heard of FogBuds, but Fog Creek Software is the software company that he created, and they created a tool, FogBugs. And what is that? That's a tool for software developers to be more effective, right? To track their bugs. So he has the experience of running a software team, making a thing, but then the experience of programmers reporting things and like, this is not helpful to me, and the UI should be like this and such, right? So that's kind of a unique experience to make software tools for software developers. The second thing is he created Trello. So Trello is a project management tool that I guess Atlassian owns now. Is that true? Yeah, Atlassian bought it from him. And then the last thing, saving the best for last, he helped create Stack Overflow. So every answer you ever get on programming, you can thank Joel and his co-founder that also created Stack Overflow. So that's why it's kind of like quoting a higher authority when it comes to talking about Joel on software. It's like, well, Joel says, and that's where we go. So you're going to see a lot of Joel quotes, because everywhere I looked, I was looking for inspiration. I have things and thoughts on rewriting, but I want to see what other people had to say, spark my memory and whatever. Everybody's talking about Joel. So that's why you're going to hear about Joel as well. Okay, so, he's based in New York and created these things. Okay, yippee. Okay, so Joel says, you can ask almost any programmer today about the code they're working on, and they will tell you it's a big, hairy mess. Okay, so that's why earlier this week when we were talking about, your experiences working on Archmage, I was very clear that what you're saying is what all programmers say always across all time, even since the 60s. This code base, it's so difficult. If only it would, and whatever, right? So there's a certain amount of that is frankly just going to be ignored. Okay, I'm just going to ignore that because that's just part of being a programmer. And so we're talking about the spikes, the things that go above the normal noise on, no, this is really bad. And how can we tell the difference between, hey, it's just a big hairy mess and all programming is a big hairy mess versus this is really problematic and something that we need to address. So that's the first thing that's given. Okay, so this is actually a real reference chart for classes in some kind of systems, comes from a Wired magazine article. That's a big hairy mess. So that really is in need of some refactoring of some kind, if not a rewrite. Okay, so how do we get bad code? The first thing is the previous programmer didn't understand the problem And that could be they didn't understand the problem at all, or they didn't understand the problem completely. So there were some edge cases, or there were some situations, or there were some integration things that they didn't think of or know about. But we get bad code because somebody fundamentally didn't understand the problem. They thought they were building the solution and they weren't. Okay. So in my career of, we'll say 50 programmers that I've worked with, in my 50 programmers I've worked with, I've never met a malicious programmer. I never met somebody who's like, I'm going to really make this terrible so that when somebody else has to work on it, like, yes, I stuck it to them, right? I have not met a prank programmer, because if you are a prank programmer that's leaving stink bombs for the next guy, your career doesn't last, right? So that isn't the issue. So the second issue is, and this is a quote, so sometimes legacy code is not written well because a preceding software development team got a product prototype created in a rush with one goal: to meet the deadline, with no attention to quality and maintainability. And so when you look back on what we did for our previous client work, the 2 games that we were working on, that was like one of the most aggressive deadlines I've ever been on, right? And so how was our code quality in that? Well, I know that people were complaining about that, and we wrote it, and it was only in 3 months. Like, it wasn't like super old, like Archmage code is, going back 8 years. We wrote it, we did it to ourselves, and it was relatively recently. And why? Because of the second one, and possibly because of the first one as well, because we didn't understand the problem completely. Okay, so we can be forgiving of the previous people, because we all get faced with this. And so I'm just telling you this not to hate on people who wrote the code that you have to now fix or rewrite or refactor. Okay, so let's be clear on some definitions as we get going talking about this. There's only 2 definitions. The first is refactor. What does refactor mean? It means to take existing code and restructure it, right? So you're working from the existing code, and whether that's a little bit of change or a lot of change, you're working from the existing code. So that's a refactor. A rewrite is new code, and you only reference the original code. When I say reference, I mean it's on another screen and you're only looking at it. You're not moving necessarily things in. Well, it doesn't really matter at that point if you actually cut and paste some lines in, but it's an entirely different thing. When you say that you're rewriting, it means file new, and I'm going to make this thing from scratch, right? Knowing that initially it's not going to be as good or comprehensive as the old, but it's going to have a better foundation and such. And so a lot of what we're talking about here today is on the rewrite side. And there is some things that are applicable to refactor, but we really are talking about rewriting. It's like, how do you know when to go and like make new code? Okay, so let's start also on the intro side. Let's talk through some things that Joel says. So we're programmers, and programmers are in their hearts architects. And the first thing they want to do when they get to a site is bulldoze the place and just flatten everything and build something grand. Okay, that's what's in our hearts. We're not excited by incremental renovation, tinkering and improving and planting flower beds. Okay, so this is the heart of the programmer. Okay, you can ask almost, I just did this. Oh, no. You can ask almost any programmer today, it's a big, hairy mess, and they'll tell you, I'd like nothing better than to throw it out and start over. Okay, so who said that here? Josh, you didn't raise your hand. That makes you a liar.
Are we talking about the entire code base? Because I don't think I've ever said that I want to throw the whole thing out.
No.
Oh, yeah, different parts of it, sure.
Yeah. Okay. There we go. I heard it all the time. Okay. So I'd like nothing better than to throw it out. I'd throw out the dungeon system and start again. Well, that's a bad one. Michael wrote it, but
I'm still planning on throwing it on starting again too.
There you go. Okay, so this is the natural inclination. Again, this is why maybe you didn't see as much sympathy coming from me, because the first thing is all programmers complain about legacy code, and all programmers would rather throw out code and start over. Okay. Okay, so there's a subtle reason that programmers always want to throw away the code and start over. The reason is that they think the old code is a mess. And here is the interesting observation. They're probably wrong. The reason that they think the old code is a mess is because of a cardinal fundamental law of programming. It's harder to read code than to write code. Okay. When you're in school, if you went to school for programming, how much code reading did you have to do? Close to none. You had to write code. You had to write these little sample exercises or whatever, where you go and you're like, make a thing to sort, or make a thing that does this. Oh, build a website that does this, right? Like you're writing new code. So you would think going into the real world that you would, that's how life would be. It's the opposite. You spend very little of your time writing something new. In fact, at grocerygateway.com, it was a real privilege to be chosen to write something new to the web e-commerce application, right? Because like 80% of the work was adding things to the existing base of this thing, right? And the chance to like, oh, there's like a whole new couponing system. Wow, cool. I get to write new code from scratch that everybody can then complain about when they have to add to it. So it is not normal to be writing new code. And so this difficulty of reading code is harder than writing code is the fundamental challenge of our profession. Okay, so this is why code reuse is so hard. This is why everybody on your team has a different function they like to use for splitting strings into arrays of strings. Insert whatever example there you would like. They write their own function because it's easier and more fun than figuring out how the old function works. Okay, this is why you end up with, hopefully not, but multiple methods in the utility class that are doing exactly the same thing, because A, I didn't look for yours, or B, I saw yours and I don't understand it. So I just made my own little one and off I went, right? So again, we're getting really ground level with our profession here.
Yeah, that's
Okay.
never happened.
That never happened, not even one time. Okay, what is the fundamental resource of making a game? It's easy to think that it's money, but it's not money, it's time. Money is what provides time, but the fundamental is time. So the most important resource of making any project, and obviously we're making a game, so is time. So all of our decision making should be based around time decisions. We'll get to that in a second when we look at ROI. So here's the interesting thing. In our studio of 10 people, there's only one person who controls the money, and that's me, right? So I just did payroll today. I have to do payroll again and again because we have 3 kinds of payroll here. But anyway, I'm the only one who's controlling the money. And so Tyler doesn't have to worry about the money. He doesn't have any control over money. He can't affect the money. But Tyler is in 100% control over his time. And so Tyler is affecting actually the most important resource that we have as a team. And all of you are touching and affecting the most important resource. We treat money like it's the most important resource, but it's not. It's the time. So this is why this is valuable and applicable for everybody. So when we think in terms of time, let's look at the concerns and the wishes, concerns, and fears of the different stakeholders. So we talk about stakeholders. They're not necessarily shareholders, but they're people who care and have an interest in what it is that we're doing. So investors, that would be me, I guess. I would also put those who have pre-ordered the game are in a sense investors. Well, I guess not in this sense, they're not investors, but anyways, what are they looking for? They're looking to get good return on investment, and many users that will pay money, right? So what is my concern? That I'm throwing all the money down the drain. That's my biggest concern, right? I could have just not made the game and kept all that money, right? That's my biggest concern. Now, I get that nobody else has that concern. And so we'll move on from the investor part. That part's not terribly important. Then we have the users. In our case, we call them players or fans. Okay. What do they care about? They really want a reliable product. And it says here, meeting their business needs, because all this software stuff comes from business people talking about business programmers. And that's usually where all the discussion takes place. We were talking about this earlier today, that game programmers, professional game programmers, don't seem to talk and publish very much in the field, right? And so that's why we're making these CodeCrafts and publishing them freely because it doesn't seem like there's a lot out there. And I guess my hope and wish, besides this helping some people, is to eventually it gets buried with lots of professional game programming people saying things and sharing things and whatever. But anyway, for the time being, it seems like there's not a heck of a lot out there. So having a reliable game that meets the expectations of the player, that's their wish, right? I want to play this game, doesn't crash, my save file doesn't get deleted, all those things. So what is their concern and fear? That it's unstable when it's needed most. Hey, it's Friday evening, I'm gonna play a game. They want to make sure the thing is stable and playable. I would also put what is their biggest concern? That we actually ship. That's their number one biggest concern. That there is a game is their number one concern. And secondly, that the game is stable. Okay, next is the product owner. And what is their wish? To follow a set roadmap. So I'm a product owner that is managing the things that we're working on. So I want to follow a set roadmap, outrun the competitors. Yeah, if we take another 8 years to finish this game, then I'm sure all the cool features, competitive advantage things that are in the game will be lost because other people have now made games with them. So I want to outrun the competitors and release features with the best final value. I want features that people are like, wow, this is amazing. I can't believe how awesome this game is. And it didn't take a lot of time necessarily to make that feature. Those are the best features. So what are the concerns and fears? The opportunity cost. So we spend time rewriting instead of releasing new features, right? So that's a huge concern of mine. I have a list of features that we need to deliver. And anytime we spend rewriting is not making that list go smaller. It's just keeping the parity of what we already have. That would be a concern of our users as well. Because in a sense, the users, the players are kind of product owners. Okay, programmers, what's their wish? To enjoy the work on the project, understand the system, code, and work with new technologies. So I hope that you're enjoying your work on the project. I know there's definitely times when you aren't, because I heard about those times. And I'm sure there's times that you aren't, and you didn't tell me that you aren't. So I don't know how much of a tip of the iceberg I'm actually witnessing, but there's definitely times when you're not enjoying it. But that is what you want. You're like, I just want a good code base that when I read my task and it says, hey, put in moisture and temperature, that I can, right? That's what I want. And when it says to destroy a town, that I can destroy a town. Like, that's all I want from this thing. I'm not asking for much. I just want it to be able to service my needs, right? And what are your concerns and fears? An unstable program, which often needs urgent bug fixing in the middle of the night or the weekends. That is definitely true in business software where, like, hey, we can't do our budget update this quarter. You got to fix it now. Or when I would get calls at grocerygateway.com, the site's down. We need it fixed immediately. Doesn't matter what time of day that was, right? Obviously in games, we don't have that issue unless you're doing like a live service game, which we are not. And so it's not so much the fact that people are bugging us in the middle of the night. I think your fear is this is always going to suck. That's a fear. And we're going to be fixing bugs for who knows how long, right? So we do finish the product, we do get it out there with the right features and whatever, and then they start pouring in all the bugs, and now we're hunting through this thing, and it takes forever to fix a bug. That's another fear. It's like fixing a bug is an unreasonable amount of time. Like, this bug should be a 2-hour bug, and it takes me 8 hours because of the code base and such.
That was definitely true of our last project as well. Like, because of that aggressive timeline, we didn't have that infrastructure. And so we spent pretty much the entire time fixing bugs rather than adding new features.
Yeah. A lot of physics rewrite. Okay. So let's start with bad reasons to rewrite. Okay. So we want to rewrite. And why we want to rewrite, when I ask you or somebody else asks, these are the reasons. Okay. It's really ugly. It's just ugly code. I don't like it. I don't like the coding style. It doesn't match the way that I would code, right? We don't want to read it and figure out how it works. It's too hard. It's too hard to figure out how this click handler thing works or the menuing system or whatever. It'd just be better if I wrote a new one. Why? Why would you say that? Because then I would understand it, right? That's the outcome that I'm trying to achieve. My goal is to understand the menu system, and my way of getting there is to rewrite the menu system, and then I'll know how the menu system works. That's what I did. Now, there are other reasons. There were very important reasons why I rewrote the menu system, but yeah, okay. It's not done the way that I would have done it. So that goes back to coding style, and it's really ugly. I don't like the people who worked on it, who wrote it. So all their stuff sucks. That definitely happens when somebody leaves a company and maybe they left poorly. And it's just like, oh, it's so-and-so. Oh, well, we probably should rewrite it just because so-and-so was the one that did it, right? So that's not a good reason. This is an important one. It was not invented here. It's not invented here is comes up with looking at the asset store and seeing like what things that we can get from there, and that's a thinking that happens is like, well, I could probably make that myself, and if I did it in just 2 days or something, what would I gain? I would know how it worked, right? If I get it from the asset store, then I don't know how it works. And I'm going to have to learn, right? I'm going to have to go through ugly code with a coding style that I don't like. And I'm going to have to read and figure out how it works, right? So that's why programmers are always invent rather than reuse what's already there. Business types are like reuse all the time. Let's stop wasting time writing things that we can just grab and throw in. Okay. Bad reason to rewrite it. The code is working, but you don't understand how it's working. So it's doing its thing, but I don't really get it. So let's rewrite it. So again, it's that seeking of understanding is really what's behind these things. You want to put a couple of new technologies on your resume. Okay. That is not a good reason. I'm not saying that has come up here, but I have seen that where actually technical architect at Grocery Gateway, I think some of the decisions he made was based on that. He was like, oh, this is cool. Now I have an opportunity to actually implement it and get on my resume. Cool. There's a framework or pattern that, maybe we just talked about, but a friend told you that framework or pattern Y is trending now, right? So it's like, oh, everybody hates on that, right? So let's rewrite that. And now everybody loves this. So these are bad reasons. Okay.
Definitely never happens in web development.
That never happens in web. No, definitely. These examples don't come from web development. Okay. So what are good reasons? We looked at bad reasons. What are the good reasons to rewrite something? So it's useless as is. So it's so bug ridden or ill-suited to what we need to do that there's no choice. We have to rewrite this thing. Okay. So the previous programmer didn't know or didn't care about what you need to do today, right? And that's a clear case that Tyler had with his moisture and his temperature work that he had to do, that 1-day task that took 78 days. So the previous programmer didn't know or care that the terrain type would change, that a swamp could be dried out into a plains or plains could be flooded into a swamp. They just never thought of that, right? So you have to go and rewrite because it's a new need that was never considered. Okay. Fundamental failures in architecture. There's, you're probably all experiencing those. Yeah. So there's I'm working on one with the towns, and Tyler said, hey, the houses aren't showing up in the town view. Like, what's going on? I'm like, oh, I think I can fix that. I know how that system works. I found a fundamental failure in architecture in the whole thing. That's why the houses don't show up, because of a fundamental failure in architecture. Next reason to rewrite: the cost of new features is too high, or it's simply impossible. So that it's not useless as is. It is working as is, but now I have to put this thing on top, and it's impossible, or it's going to take me so long in order to do that. It's just like not reasonable. Performance. Old one is inefficient. We've done a number of rewrites along the way. The map was rewritten for performance. How we displayed the icons on the map was rewritten for performance. We're going to do one, which is we have 7 days allocated for improving performance and the data model that's behind the Mage Tower. So that one is still coming. So why would I make that decision? Because the performance is just too inefficient. Okay, next one. Onboarding new developers on a project gets too complicated and takes more than 2 months. So those aren't my words. I grabbed that from somewhere. I thought you'd find that funny. I was like, yeah, it takes more than 2 months to bring somebody on. Wow, this thing needs a rewrite. When it came up earlier this week, what if? I thought about what if we just started with a new code base and started writing things and as a rewrite, meaning using the old code as reference, but we're writing all new code. That was one of the things I was thinking about. I was thinking about that onboarding time. Is it possible to get that down? Next, simple bug fixes take up way too much time, right? So that was going to the fear factor of I'm going to spend a day fixing a 1-hour bug. And that's going to happen day after day after day because of how convoluted it is, or because of the messaging system that's firing off these messages all over the place, and I can't trace the call stack, all that. It could be that while you're bug fixing, there's kind of a smell that may be hinting at a deeper system issue. So you're looking for this one bug and you discover this is actually just a symptom of maybe this larger issue. And so that's a good reason to rewrite, is you're like, there's a lot of smell in this area of the code. There's a platform or scale issue. So it may be like right now, we were just talking about some maps, and our dev maps are what? I don't know, 30 hexes by 15 hexes or something like that. They're not very big, right? But our actual map is going to be like 200 hexes by 100 hexes. So suddenly the thing doesn't scale to that. That was actually the reason for the rewrite that we did, was a performance reason. It was impossible to play the game at 200 by 100 hexes because we spent so much time with it being like 20 by 10. Or there's a platform need in terms of, Steam has changed or Xbox has changed or something. And so we have to go and do something. This last one is subtle and important and comes from experience. Bug bounce. So what is bug bounce? Bug bounce is, hey, there's a problem with, let's say the map where the terrain is keeps flipping. It's like ice, and then it's plains, and then it's ice, and then it's plains, and it's like, okay, you go in, you fix it. The situation that you could reproduce doesn't reproduce anymore. You fixed it. And then somebody else reports the same issue in a different way. And you're like, oh man. And you go in and you fix that one. And you're like, okay, I got both of them. Like, it's pretty solid now. And then somebody reports the same thing. That's bug bounce. It's the same bug, but it's rearing itself again and again. Either you thought you fixed it or you hoped you fixed it. That's definitely for situations where it's not easily reproducible, or you can't reproduce it on your machine, but you see from the video from their machine that I see exactly what they did, and it's like, oh man. So you can program defensively and think that you fixed it, but the bug just keeps coming back. So the permanent solution to bug bounce is a rewrite. Refactoring will not solve bug bounce. I'm telling you that from experience. So there's been many a time where we have numerous bugs, we fix them, and we're just like, man, we just keep fixing and fixing and fixing. And that's how you know, okay, if there's bug bounces, it's time to rewrite. A good reason to rewrite is no one can figure out how it works. And so it's not just it works. It's fine, but nobody knows how it works. I have to do something and nobody knows how it works. That is a good candidate for rewrite. Now, there's a caveat to that maybe you haven't spent the time figuring it out, or maybe you're not the right person to be the one that's working on that. Maybe somebody else will be able to figure it out or whatever. But anyway, if nobody really can figure out how this thing works, then that's a good case. Okay, this last one is, I am now feature me. Okay, and we understand the problem better. So whenever you are working on something, you have a certain known or a certain visibility of the problem and the domain. And at some point in the future, you will know more. Okay, nobody knows less in the future, generally speaking. So future you will know a lot better what this thing should be. Okay, so I'm future me of 8 years on Archmage. So I know a lot better now how Archmage should be programmed than I did that first year. Okay, I now know the menu system is going to actually be used in a dungeon, because you can like have a conversation with somebody in a dungeon. Never thought of that earlier, not because I was going fast, but I just never thought that was a feature required. Okay, so a good reason to rewrite is I'm now future me and I now understand the problem better. And so in an example in this town thing, there's like multiple things that are clickable. So there's a thing like a house or something that's clickable, and you move the mouse cursor over, it highlights whatever. That was programmed in a list so that there could be multiple things that highlight all at the same time. I have no idea why that was. But now 8 years in, when we're closing in on finishing the project, I know for a fact that is not a need. And so as I am rewriting, I'm rewriting for other reasons that are higher up this list. But I am now future me, and I know we don't need that stupid list thing. And there's all this code which just grabs 0 on the thing because somebody got faced with the list and they're like, I don't know why there's a list here. So they just grab element 0 and just move on with my life, right? So even if somewhere did need a list, it doesn't work anymore because people are using the 0 element of the list. So you're now future me and you can understand it better. Okay, so while you're looking at this, you have a reason to rewrite. These are things did you consider? And these are things I want to impress upon you. That comes from experience. So the existing code is tested and proven in battle. And do not underestimate the value of that. The fact that it has been working for some period of time, it is easy to go, yeah, well, but I'm going to write new code and that'll work as well too, right? It'll be the same. It's not the same. It's usually by the third version that code is good and solid. So there's the first version where you think you understand the problem, and that's what you write, and that's what you check in, and that's what ends up going out to people to experience. Then the bugs come in. Then you go in and fix the bugs and refactor according to those bugs. And that usually happens 2 more times, and now it's solid and proven. And so this is really important. I'm going to give an example. You're starting the clock over. So here's an example from my life. So I leased a minivan. And so my family's driving around this minivan, and it was blue. So we're driving around in a blue minivan. And then my wife hits a deer because everybody on this island hits a deer. And she hits a deer and she totals the minivan. And then they say, good news, we're going to give you back all the money that you owe on the minivan through insurance. And now you're at 0. And now you can buy a new minivan. And my wife is like, that's not good news, because I was 2 years in to finishing off paying for that minivan, right? Like if it takes 5 years to pay off the minivan, I was already 2 years in and only had 3 years left to go. But now we're starting over with a new minivan. It was only like a model year that's 2 years later. So it's like not fundamentally different from the other model. And now we have to start all over again. Now we have 5 years that we have to pay for this minivan. So in total, I'm paying for 7 years of minivan when normally I would have been paying for 5 years. Okay. So that is what's true here about the code. So when you choose to rewrite, you're restarting the clock. You're starting the lease anew on the code, and we're going to have to pay for it by having 2 more versions on top of this. So if you can reuse that already proven third version of something, that's a good thing. Okay. And this is subtle and not easily seen. And that's why I'm sharing that. Rewriting the code always takes up more time than expected. There's a global stat on this that somebody quoted, and they say it's underrated by 30%. I actually think it's a lot higher than that. I don't know where the 30% comes from. But anyway, so when I was faced with this with one of my customers, Vortman Cookies, and they had a software system that they paid $1.5 million for somebody to build so that they could deliver their cookies to all the stores, including Walmart and whatever. They were all throughout North America and including Puerto Rico. It's very rare to have service throughout continental US and Puerto Rico. Anyway, so they have this system, they pay $1.5 million for it, and it doesn't work like at all. And when I say it doesn't work at all, they had to hire 20 new people in finance just to figure out all the invoices that were wrong and the credits and debits that were supposed to go to the correct people. So you would have a guy who's a distributor of cookies, and he paid $1,000 and he was supposed to pay $1,100. So somebody has to go chase down the $100. Or he paid $1,100. He was only supposed to pay $1,000. And when you got to write a check and get it out, 20 people were hired in order to handle all the problems coming out of this bad software. So what did we do? we went, they said, Thomas, we need your help. You guys know mobile software. Can you come in and fix this thing? And I'm like, yeah, we can try. I mean, I didn't write it. I don't know how bad it is, but we'll do our best for you. And it was about 2 months in. I'm like, this is a rewrite for all the things you saw on the good list. This thing's a rewrite. And they were like, I don't think we can rewrite it. And I was like, okay, like politically, it's not going to get approved to do a rewrite. We have to just keep fixing. And so I told them, honestly, I think we could build this thing for about $200,000. You have already spent $200,000 with my software company just trying to fix the thing. And I could have written you a new one for about $200,000. And that was kind of compelling to them. And they kind of floated that up the chain and eventually said, well, you know what? You make a good point. We don't want to keep throwing money down the hole with fixing this thing. And one of the reasons that I was doing it is because the guy who was working on fixing it came to me and said, Thomas, I just can't take this Visual Basic anymore. I just can't do it. I'm like losing my skills. I am a dumber programmer having worked on this Visual Basic for the last 3 months. So I had you're laughing. I had a serious employee issue, right? And I was like, this guy's going to quit if I don't get him off this thing. So I got to do something. I got to convince the client to let us write a new version in C#. And so I went back to them and so they said, okay, let's do this rewrite. And so we sat down, we wrote out a spec. There was like 8 or 10 people in the meetings and I would ask them, do you want it like this? And here's a mock-up and whatever. We went through all those meetings and you know what the price was? $450,000. And they're like, what? You said 200. And I was like, oops. That's a funny short version of the answer. The larger answer is you had 10 people in the meeting and they were all asking for their individual features and stuff. And basically you feature creep the thing. So the new version is going to do a lot more than the previous one, whatever. But anyways, I use that as an example. Like it's really easy to look at it and say, oh, I should be able to make this for 200,000. And it actually ends up being 2.5 times what I said it was going to be. Okay. So they say the global stat is 30%. So it's always looks easier to rewrite. Mere rewriting brings little value to end users. Okay, so every fan that's watching this thing and going, oh man, these guys spend like 2 months rewriting parts of Archmage. All of this is delay the release by 2 months, right? Like it's the features that need to be done. So it's just kind of treading water. It is possible to make the same bugs that your predecessor did. So once you really get into it, you can introduce the exact same bugs. And we're really no further ahead at that point. It's not very likely, I would say, but it is possible and it's something to consider. But the most important thing is that you will create new bugs. So you see the existing code, you see the problems of that. But what you don't see is the new bugs that you're going to create. So is rewriting faster than refactoring? So what is refactoring? Going and changing and working with kind of, somewhere within the system. Now, where that circle of concern is expands out more and more and more, maybe as you go along, but it's not the same as just like, yeah, I'm just going to rewrite this thing. So how do we figure that out? And the answer is it's complicated. Is rewriting faster than refactoring? It's complicated. So how do we figure that out? So old code, this is Joel saying, the idea that new code is better than old is patently absurd. Old code has been used, it has been tested, and lots of bugs have been found and they've been fixed in that old code, right? You would have to go and look at a Git history in order to really know how many times this thing has actually been changed. You're just seeing it in its current state. Code doesn't acquire bugs just by sitting around on your hard drive. So just the fact that something is old does not make it bad. So I want to talk about the visibility issue. And so at the time when you're deciding to rewrite, you need to be well aware of the visibility issue. And so that's what I call it, the visibility issue. You only see what is wrong with the existing code. So you need to know that. You're not making a fair assessment. You're only looking at what's wrong with the old and how great the new will be, right? That's a really easy decision to make. Column 1, all cons. Column 2, all pros. Hey, we should rewrite, okay? You do not have visibility in what will be wrong with the new code. And, that's a hard thing to appreciate. And as I've put the decades under my belt of programming, I start to realize, there are going to be things wrong with this new code as I go through. It's kind of inevitable, right? So be aware of that. Visibility is based on how well you know the system. So it's easy on the first day, the first hour, to go and look at something and go, well, this is completely terrible. I can't use this. This will never support what I'm doing. I need to rewrite this. You probably don't know the system well enough so that when your visibility of what exactly you have to rewrite is very, very limited. Only when you know the system well can you really do that. And so when I decided for this houses thing not showing, and I was like, we need a sprite caching system in order to support this. That's because I know the system well, that I can make that determination. And so there is no shortcut to it other than asking somebody who knows the system. That's the answer, right? So if you don't know, you're like, okay, great, Thomas, I don't know the system well enough to make this rewrite decision. Then you ask. And really the only person to ask is, I guess, me. Maybe you can ask Michael, depending on what his impact was on that particular thing. Basically, if it's dungeons, you should ask Michael. But for a lot of these other things, like the bird's eye view of the towns and whatever, then I kind of know how that system works. I didn't know it was as bad as it is, but I kind of know how it works. So I can answer that. So this is why juniors and new people, noobs to the projects, you might be a senior software developer, but you just came here to Defiance and now you're working on the thing. You shouldn't be rewriting things. That is a bad mistake to start going to rewrites. Okay, you should be in the refactor camp. So how do we evaluate the existing code? Does it do its current job well? I think a lot of you would say, no, it doesn't. Okay, so that's why I put the next one. Does it do it satisfactorily? So can I satisfice with this code? Because if it's okay, and okay is a very low bar. If it's okay, then I don't have to waste my time doing that. I can move on with my life, get a feature done, and work on other parts of the game, right? So is the existing code, does it satisfy me? When I'm building on this existing code, how much shake can I accept in the building? How much sway will I accept in the building? And if your answer is none, I accept no sway, and it has to be written well, otherwise it requires a rewrite, you are a purist and you belong in academia, okay? You do not belong in game dev where we ship products. The way you ship products is this satisfactory, and how much shake in the building will I accept? I accept 3% of the wind moving the building back and forth, okay? Because the cost of less movement is so high. So those are, I think, key questions for when you're looking at the existing code. Now let's talk about return on investment. So return on investment, very general way, is you look at how much investment am I putting in? $1,000. What's my return going to be? $100. Okay, so it's a 10% ROI. And usually when you're looking at ROI, it's over time. That's a factor that's not shown here. So it's easy to say, hey, look, I made 10% of my money. 10% of your money in 10 years or 10% of your money in 10 days. Those are very, very different ROI situations, right? So if I can make $100 in 10 days, I think I'll go for that, even though the percentage is small. So that's what we need to consider as we go and we look at this code. This is how you reach the conclusion of should we rewrite or should we refactor this thing. So what is a reasonable return on investment? So back in my software consulting days, we were working with Staples, which is a very large office supply company in throughout North America, maybe even other countries. I don't know where else they may be, but Staples is real big. And one of the most infuriating things about working with Staples, and I don't care if they watch this video and they know it, one of the most infuriating things of working with them is that they would not spend $1 on anything in terms of software, process improvement, anything, unless they're going to get $4 back. Okay, so that's a pretty good rule of thumb, actually. For every $1,000 that you spend, you're saving $4,000. That's pretty good ROI. And so when I was thinking about this, of what metric to give you, I think that's a pretty good metric. I mean, I mean, 5 is better and 10 is better or whatever, but this 4 times, that's pretty good. So if you can spend 4 hours on something to gain 16 hours, that's really good. If you're spending 8 hours to save 8 hours, that's not very good. I don't think I would approve that for all the reasons we just described about old code being battle tested and whatever. Do you understand it well enough and all those things? But if you're coming to a conclusion of a 4x ROI, then rewrite and major refactor is probably the right thing to do. And so, in our case with the save system, I think we're forced into it. There was just no way to use the old save system. Is that right?
I think so. I mean, I did realize that we could have looked into a few more options because we were kind of talking about here is the old system that we were using and here's the other old system that we were using, but we weren't able to get the bug tracking, or we weren't able to get the information that we needed. And so when we were looking at, hey, is this based on our tests in the past, we kind of saw that it wasn't battle tested because we would spend like a day looking for a towel or things like that. It's like, we're going to lose so many days as we're approaching launch for any save bug given this current system.
Yeah. So that's a good example of, spending a day trying to find one of these things. So I don't know how many days it took in order to make the save system, 7 days, 10 days.
The core of it, a lot of it has just been the integration time. The core of it, it might be fair to say 7 to 10 days.
Okay. So on a 4x scale, are we saving ourselves 40 days of work? And I think the answer to that is yes, maybe even higher than that. And one of the big advantages that you have with this team of having 5-6 programmers here is it's multiplied by the other programmers, right? So when I make the sprite caching system, that is something that will save potentially all of you time, potentially, right? It's not a guarantee. And so that getting to the 4x is probably pretty easy, right? Because I spend 4 hours on something. If it saves me 4 hours, Zach 4 hours, Tyler 4 hours, Michael 4 hours, I'm already past 4x, right? So when you're doing these kinds of things, it's easy to get to the 4x, I think. Okay, so then this comes up with the question, let's zoom in on, so how do you know when to escalate the scope of the change, right? And this is what Tyler's question was earlier this week of, okay, so you're trying to solve the house thing not showing, and now suddenly we have a sprite caching system in order to solve the one problem, the houses aren't showing, right? How do you make that judgment call, right? That's the question. How do you make that judgment call? So I thought about it, and these are my answers, Tyler. Because you're forced into it. So the rot goes far. I need to keep increasing the scale because I'm like, oh, this is a problem and this is a problem and stuff. So it's touching multiple things. It's affecting multiple things. The rot goes far. So you're forced into increasing the scope just because that's what the actual scope is. So it looked like I had a house problem, but I don't have a house problem. I have a reading all resources in a folder problem. And now I have to change how that is done. The second is the ROI. Am I expanding the circle of beneficiaries on this? And so I believe that I am. It's not affecting just the town house display. It's affecting every hex displaying anything. So when you go to a hex and you see trees in the background or you see water or whatever, it's the same system that is messed up that is affecting that. So it's not just the one house. It's anytime we look at a hex. So how do I know to escalate? Because the ROI is guiding me into like, this is a big savings across the team or across these additional features that I have to add. Only change if you understand the consequences of your actions. Otherwise, leave it alone and work around it. So I do know how all of these, I think there's 3 or 4 levels of this system for displaying a house on the screen. I do know how they work, and I do understand the consequences of that. And that's why I'm like, yeah, I'm just going to strip all this out and put in the new stuff. So that's my answer. I don't know. Does that help, Tyler?
Yeah, I think so.
I think you said, I think so.
Yes.
Okay.
I don't think my mic is being picked up very well.
Okay. Okay. So a good solution has to solve the problem in multiple places. If you're going to rewrite and look for that ROI, it has to solve the problem in multiple places. So not just houses for the town, it also has to solve showing fields and trees and non-town spaces. It has to have constant use. So what is constant use? It's frequency of use, right? So if it's the small little area and nobody really touches that, it's just like one thing, then that doesn't need to be rewritten. That can just, we can put up with the stink over there because it's far from where everybody's walking. So in this case, I found out that I just couldn't stand the 100 times calls to fetch an image loading all the sprites in a folder. And that's just to determine which sprite to show. But then also when it goes to display the sprite, it also has to go and load all the sprites from the folder. And that constant use of the thing is just like, this is no good. This can't stand. It will probably create more problems for us. The fact we were already having problems because somebody created a rubble image, put it into the folder. That's the right place to put it. Whatever. Now suddenly buildings show up randomly as rubbled, and then that creates a question like, why is that building damaged when it's not damaged? Why is it showing as damaged? Because it's reading all the images in the folder and just plunking them down. And so that's a constant use example. And then the third one is the solution has an immediate use and applicability elsewhere. So if I rewrite this thing and I make this sprite caching thing, does that have applicability elsewhere? And the answer is yes. To me, in hindsight, it's kind of silly that we don't have a sprite caching solution because we have sprites for the hexes. We have sprites for the icons that appear on the map. Now we're putting in these animated icons on the map. There's a lot of UI elements that we don't need to read from the resources, resources.load all the time, right? It's just, so it has immediate use. I can immediately use it for my problem and applicability elsewhere. So that's a good indicator for a rewrite for that ROI. And the last thing is I want to try and end every CodeCraft with programming like a Spartan. If you remember that a long time ago, we had, we were talking about process of game development and how do you know how to name things and such. And so we talked about program like a Spartan. So Spartans fight only the battles that they need to. That's the only thing I come up with for programming like a Spartan. Okay. And that is the end of my thoughts on answering that question.
I think the biggest thing that came to mind during pieces of it, I mean, first off, yay, I think that's good and helpful and good to talk about. Second thing is one of the things that you mentioned is that the code's been tested. And there are cases in the project where that has been true. There are cases, for example, code that we were writing just before we started working with our client, where we wrote some code and then we jumped off, where there was a lot of code that wasn't tested.
Yeah.
Or there's code that it's connected to things that were tested, but it wasn't tested with that and so on. There's even, I guess this gets into some of the other things that you were mentioning, but where it hasn't been tested with the new system. And so there's kind of a struggle there. So I don't know. I guess I don't know if there's really a question in there, to be honest.
That's a comment then. Yeah, I agree with you. So that would fall under the not tested code, right? So how much weight should you put on that code? The answer is not a lot, right? Because it hasn't been tested.
It's not version 3 yet.
It's not version 3.
Various stuff on the code base that is tested, Josh. I mean, a lot of it isn't, but like there are certain pieces where, so like if we're talking about dungeons or something, you guys are looking at some issues with pieces here and there, and like the code's broken there, but you don't need to like go rewrite the entire like how the layouts of the rooms are working to solve your problem. And so like, because that's stuff that hasn't been used and been tested and it's been working. But yeah.
Yeah, I guess that the main case that I think of, which we're both working on, and that has also affected Sean and has affected Tyler and has been affecting everybody, is some of the recent map rewrite stuff. Some of the recent things with even how the trolls move and some of the animations on the map and all that, where like, for example, I mean, Thomas used to talk about we move really slowly on the map because it's this really slow tween that's like, let me take 10 seconds to move you to this hex. And so there's a lot of stuff there that wasn't tested. Or it might have been tested by somebody and they're like, it works.
Yeah, it's not good, but it works.
Yeah, it doesn't solve the problem really effectively, but it works. Like it fits the spec sheet sort of thing.
Yeah.
Yeah.
It matches the letter of the law, but not the spirit of the law.
Yeah, exactly.
But I think even those examples, like we got to the rewrite, maybe not strictly following the process laid out, but a lot of those questions were asked and answered. Yeah, like I think like the ROI is probably a good example of like lots of people are using it. So it makes sense to rewrite it because it's blocking all these people from getting work done. Yeah, you know, like I think those are examples that fit within what's been presented, not, I don't think they counter it at all. Yeah.
I guess a question I would have sort of in summary is, do you think that ROI/time invested is sort of the golden rule of when to rewrite versus refactor?
Yes. Yeah, I was just thinking about that. I'm like, okay, you know, if we could sum up with like kind of one takeaway, and I'm going to turn a bunch of this into a knowledge base article so that it's referenceable, you know, later. It's hard to go through a video and like, what was slide 3 or whatever, right? So I will write it up. But that ultimately is the big takeaway. How do you know when to rewrite? ROI. And if your ROI is, oh, it'll take me 4 hours, it'll save me 4 hours, then don't do it. It needs to be take 4 hours, 16 hours is what I save, right? Or it's 4 hours times 4 people is what I save. That's what you're looking for to know when it's rewrite. Otherwise, just work with what you have, because what do we need to do? Ship a game. And are we shipping the source code with it? No, we are not. We are not shipping the source code, and nobody is going to pay us extra for prettier, nicer source code. Right? There's a certain factor there of like we're paying ourselves by making it easy to find bugs and fix them or whatever. But in general, no one cares how good the source code is. I can't believe it's coming out of my mouth because I'm really big on like it needs to be done well and whatever. But anyway, at the end of the day, they want the game done and they don't care how pretty or nice the source code is. So given that we have this, a lot of code, and maybe 80% of it sucks and it's terrible to work with. But the cost of rewriting that 80% is just too high at this point, right? And the example that I gave earlier this week was Duke Nukem Forever. We are currently 2 years under the Duke Nukem Forever timeline, right? And people are going to start calling this Archmage Forever. And maybe that's what the sequel should be, Archmage Rises Forever. Anyways, one of the reasons, because that's a real outlier in the games industry to have something so public go so long and be so terrible, right? Like there's terrible, terrible games, but they're not public. Or they're terrible, terrible games, but they didn't take that long. There's games that take a very long time, but they weren't that terrible, right? But this is like the trifecta of terrible game development and one of the core reasons was they kept restarting. They kept going, oh, it doesn't allow us to do the kind of flying, battles that we want to do in flying cars and whatever. And so we're going to change engines and we're going to like start all over and whatever. And so they didn't have any of the old problems, but they had a ton of new problems, which they didn't account for. And so I don't know because I wasn't there. I've only read about the people that were there and the situations that went down from multiple perspectives. The guy, George, I forget his last name, starts with an R. It's like Rocio or something. George, he wasn't respecting the value of old code as he was making these decisions. I like to think if they went through this little PowerPoint that I went through, then Duke Nukem Forever would be a great game. Isn't that a prideful? Anyways, I'm probably overstating it, but that's kind of like the thought process to go through. And they did not, right? At certain points, they just said, well, we don't care. We're going to rewrite anyway. And then you end up with what they ended up with.
So just to make sure I understand, you're saying that like,
I could have shipped Duke Nukem. Yes, that's what I'm saying.
No, but I'm more talking about the golden rule. I mean, yes, maybe that's true that you could have shipped Duke Nukem. But coming back to the golden rule thing, you're saying 4 times. Is that because, like, say, the one-to-one example you give, you're going to underestimate how long it will actually take you to execute that? And even if you did get it bang on, you got a 1-for-1, there's probably somewhere else where you can get a 4-to-1 return on your rewrite?
Yeah. So as a business, it's dumb for me to spend $1,000 to save $1,000. right? Because I'm net neutral, right? It's zero in terms of gain. And so that is true for you in your time, right? Don't spend half a day to save yourself half a day. Just do the thing and move on.
Okay.
So the alternative to rewrites is refactoring. It sounds like, one of the big problems we have is that, as you mentioned at the beginning, it's harder to read code than it is to write code.
Yeah.
I'm curious, do you have any and this might be a different topic, but I'm just curious on quick tips on how to read code that may be bad or was written by somebody else, faster, better, etc.
Yeah. So the shortest answer to that is useful is to diagram it. That's what I did. I used Visio as I was going through because I couldn't once I got to the 5th level, I couldn't keep it in my head anymore about all these indirect calls. You know how they say in programming that you should have these tiny short methods that only do one thing? That's a nightmare to follow, right? When you're trying to read the thing, the legibility of it goes way down. And I don't know who out there is saying that you should only have like these tiny little methods that do one thing, but I want to spank them all, every single one of them. They deserve a spanking. So there is something great about the big 80-line method that I'm like, oh, that's the thing that shows the image on the screen. This thing does it. And so, yeah, I was using Visio in our diagram. You can use any tool you want, but that's the only way that I could comprehend the code and realize where the rot was and how deep it went was in diagramming it. So previous CodeCrafts showed you how to do activity diagrams, sequence diagrams in order to be able to document these things. And so that's a way to do it. It's not just for creating new code. You can actually document existing code to increase comprehension. And when you do document, let's say that you're working on something, Michael, and you go through and you're like, yeah, I'm trying to understand this. You got your sequence diagram, your activity diagram, or whatever. Then you're like, I think this needs to be rewritten. You can take the diagram to me and say, this is the current state. I think it needs to be rewritten. I look at it and go, oh yeah, you're right. Right? Like that's a huge advantage of that.
We should just show them the dotted line chart from the presentation.
That's
the current state of this.
Yeah.
And even if you're not rewriting it, would probably highlight here's a place where you can change a couple things to make it better.
Yeah, that's a really good point because, like maybe a small refactor actually is 50% of the rewrite effort and way less time. So, yeah, it's a really good point.
Yeah, so we made the decision earlier this week, we're going to work with what we have. And we're going to keep bolting on new features to what we have. But a second thing was that Michael went through and looked at the features. So we had a second opinion on the features. And the features are generally new and kind of exist outside of existing systems. And that's intentional because we're trying to add breadth to the game. As opposed to, let's say, making combat even better and combat even better and combat even better. That's not the nature of the work that we're about to do.
Something that I think is worth bringing up with it is, and I don't know if this is just something that works for me or if this is useful for other people, so I don't know, maybe it's just throwing out as questions or thoughts, but it's I'll usually refactor while I'm reading code to help me process it. So it might just be that you have like all these variables stuttered throughout this method. And so I'm like, okay, I'm trying to figure out what's going on. So I'll move the variables to the top, or I'll switch some things to const, remove magic numbers, add summary comments as I'm reading through code, just being like, what is this doing? And so that's usually what I'll start with. It's just like rather than read through the code and be like, I can't figure this out, I'll start to move things into natural groupings and then I'll be able to read it a lot better. I don't know if you have any thoughts on that or there are certain things where I'm like, this might change how it works if I move this, but there are pieces where it's like, this won't change how it works if I move it. I'm just going to rearrange this a little bit so that it's more readable. I don't know. Do you have any thoughts on that? Or
I think that sounds really good, especially for the kind of person that you are. Like that's really like getting your hands dirty, right? As opposed to maybe diagramming is a little too separated or something. Like that's a way of like getting into it and trying to understand it. At the end of the day, whatever you do to help you understand it is perfect.
Yeah, I try to make sure it helps other people understand it too, because maybe it took me 10 minutes to figure out what a method does. And I'm like, I'm going to try to leave a summary comment there so that other people don't get confused too, or maybe I'll do a rename or things like that.
I exactly the same as you. I'm like going through this code and going, I'm not going to remember what this method does. So I put in a summary comment so that when I'm going through it, I can mouse over and oh yeah, that's what that thing does again, right? Because I have set image, set visual item, and I'm like, which one's actually changing the sprite? I don't remember which one, right? When you're 7 layers deep, and so I have to throw a comment on it, and so that makes it better for the next person too.
That's good ROI too, then, because you understand it better, and then other people are understanding it better. It only takes a moment to put in the comment. So
once you figure out what it is, the cost of writing a comment isn't that hard.
Understanding
that's hard. So.
And I guess I
was going to say, you increase or rather decrease the time that someone else spends understanding it, which is good ROI.
And I guess the piece that I'm kind of throwing out with there, although you can definitely take this too far, is that sometimes rewriting helps with processing versus like, I have to understand exactly what this is doing before, because you can just move variables around, and unless it's being changed in multiple places, it's like, I can do that, and that's perfectly safe, or stuff like that. So it's just, kind of trying to parse some of that. Or, hey, here's a comment that's not a summary comment, and I came here looking for what this does, and it's going to make that a summary comment, or things like that.
Okay. Is that it? Okay.
There was one other thing I was going to throw out, and that's just one of the things that I've seen that seems to be helpful as well is that refactoring seems to be a lot better when it comes to when we're trying to merge code. Because if we do a rewrite, then it's like, oh crap, all the hooks are broken, and I don't know. Maybe that's a sign of just another approach needed in those cases, or maybe it's just it seems like. I think that we've all communicated well when we are looking to rewrite something. I don't think I've seen anything where, who rewrote this and what happened and now nothing works. It seems like there's generally, I don't think there's ever been a surprise on the team for that. I don't know, if there is, it's probably been my fault. But I don't think there's been any surprises on that. So, but it does seem like refactoring is cleaner for merging.
That's a great point. Thank you for bringing that up. And I forgot. That's a really good one. Like when you're looking at it, that's a consideration, right? When I had that slide about, hey, did you consider? That's actually one of them. Is like the code merge could be quite brutal, and I don't know if we've had code merges take longer than a day. Have we had that here?
Maybe 2. Well,
we did on the client project, I think.
Okay. Yeah.
There was a couple days. There was a few days of merge errors that I think me and Michael were working on or something.
So when you're looking at some code and you're like, hey, I'm gonna rewrite this. You're only thinking about the time spent typing at a keyboard. You're not considering the code merge time on other people and whatever, right? And that's what that's trying to get at is like, hey, be aware that there's a lot of costs involved, and existing code has already passed all those, right? The price has already been paid. And so you're creating new costs potentially. So that's a good point, Josh.
Thank you. Since you're bringing it up, Josh, I will mention if you're refactoring stuff and you're moving it into a different file and creating new files, if that code is already existing and been touched, it's probably better to actually move that over on develop or on some other branch.
Yeah.
Because the conflicts aren't tracked when it's a new file. And so ran into that a couple of times, and that's a problem. So
yeah,
if you're doing cleanup, sometimes it does make more sense to just go back to develop to do that cleanup and then change your things. Right. Even though I personally would love I'm here, just fix it now. If you split it apart, it makes it easier to separate out from your pull requests, separate out from other stuff people are doing. And
That kind of does hint at a big issue I think we have where we really need to make sure that commits are consistent with like what we're working on.
You mean branches or commits when you say
well,
it can be both.
Yeah, depending on how you want to do it. Like we tend to not use branches, but trying to keep like things together that belong together essentially. So that's what Mike was talking about. It's like that I need this change, but it's not really specifically relevant to what I'm doing here.
Okay, well, let's cut it off here. And I want to thank whoever's out there watching this. I hope that this has helped you in some way. And if it was, like and subscribe.
Yeah, when we become this mess,
no, we would love to hear from you that the recording this is helpful to somebody. And just knowing that it is makes it worthwhile to record and publish and whatever. I just today made all the previous CodeCrafts, the previous 9, public and searchable and available. And so that's my hope, is that somebody finds them useful. Hopefully more than one somebody, but anyway, somebody finds them useful. So, okay, great. Thanks, guys. We'll see you.
Yeah.
Yeah.